For all you crazy anatomy fans, we started displaying.
Okay.
Oh,
All right, so we didn't bother with the respiratory system yet, so we're just going to use this for the circulatory up here, right? So this is, we'll start with the heart and then I'll do the other organs after, all right? So the heart, right, the bottom of your heart is the, what chamber goes to the bottom of your heart?
The right ventricle.
Really?
No,
left ventricle.
left. Oh, I'm looking at it.
Left ventricle, right? That's the oxygenated blood. But in your fetus, it's the other way around. So that sash here, that's actually the coronary artery and vein, the left coronary artery that sits in there. And some of them comes out stained really nicely. Meanwhile, these little doggy ears, these dark areas here, 1, 2, can be called little ears. In Greek, that's auricles, which is another name for atrium. Right, so that would be on your left is the right, and your right is the left. So coming up from the right ventricle is the, ooh, look at this big white thing. I wonder what that is. What do you suppose that is? Looks like a big fat blood vessel.
That's the systemic aorta.
Coming from the right. Remember, it's all twisted, right? So this is from the right side, the right ventricle. Right, so the one that's obvious here in the front is the pulmonary aorta, not systemic. So that's the pulmonary aorta coming right out. Behind it, coming from the center, which is the left ventricle from the bottom of the heart, coming straight out is the systemic aorta. But if you keep going up straight, this first big branch, you end up in the brachiocephalic. So that's the brachiocephalic, which branches into the right subclavian and the right and left common carotid arteries. Right. Here, in order to show that up, remember what I had to cut? This big fat blue thing I had to cut. What was that? Anybody remember what that was? Nobody remembers. The superior vena cava, right? Remember veins, they look blue because the color of whatever's inside shows up because the walls are very thin, because veins carry blood at almost no pressure. Whereas the arteries all look white because they're covered with a thick connective tissue coating, collagen, in order to hold in those high pressures that you find inside. And then as we go along the systemic aorta, which actually arches back, right, here's the branch, brachiocephalic, or it arches back into the systemic aorta. The next big branch is the left subclavian. So it's not quite symmetrical, right? The right subclavian is a branch off the brachiocephalic. The left subclavian is a branch directly off the systemic aorta. So that's the only kind of intricate, sort of blood vessel detail you should know is the arterial tree. Systemic aorta, brachiocephalic artery, right subclavian, right and left common carotid. Next off the systemic aorta is the left subclavian, right? Subclavian under the clavicle, under the collarbone, because it goes out to the arms, or the forelegs if you're a pig. Sorry. It's all right. Okay, so now, if you go back, if we go along here, we see that the systemic aorta and the pulmonary aorta just run smack into each other because the pulmonary, although you can see, I'll show you here, see how the pulmonary branches into the left pulmonary aorta here. Most of it actually runs right smack into the systemic aorta coming in behind it. So there's this very short, very fat artery, which is called the, it's only there before you're born, right?
The one that shut.
Yes, it's a shunt. It's called the ductus arteriosus. The ductus arteriosus, very fat, short vessel that connects the pulmonary aorta to the systemic aorta, and this pinches right off at the moment you're born when you take in that first huge breath of fresh air. The surge of high pressure, air pressure inside your chest triggers the closing of that, as well as the closing of the foraminal valley inside the heart, which we don't see because we don't cut the heart open. And in the sheep heart, that's a mature heart. It's not there anymore. Okay, so that's the heart. And then going around the other side, if I pin the heart this way and I plant the flag in there and I say, name this blood vessel, you'll say, well, it's blue, right? So what kind of a vessel is it? It's a vein.
Inferior vena cava.
See? Okay, there you go. Maybe I'll ask that just to give you all something everybody will get, right? Inferior vena cava. This also shows up really well. And now, so that's, other than that, for blood vessels, while we're on the subject, remember that we have the two umbilical arteries and the umbilical vein, which was the first vessel you cut in order to open this abdominal cavity, right? So that's where it was cut. So there's the umbilical vein. Goes back through, underneath the liver there and ends up joining the inferior vena cava. The only other blood vessel you should be able to identify from, well, I probably won't do it this way, but you can see that the descending aorta, it descends and it shows up all the way down right on top of the spine, but because there's still a little blood in here, you can't quite see it. But you got to push these other organs away. Well, probably better to do it that way. And now you can see in there, you see this big fat white vessel. That's the systemic aorta. Right? Sometimes they call it the dorsal aorta because it's right on top of the spine there, right by the in the dorsal area. Now we can go over the rest of the organs, right? So this is all in the thoracic cavity. Sometimes they call these the pleural cavities, and they call this the mediastinal cavity. This is all basically the thoracic cavity here and the neck region up here. In the abdominal cavity, the predominant organ size-wise is the liver. It's a big, important organ for all of us, but it's in particular in the fetus or in a baby, the liver is unusually large. So our little kids have their cute little tummies sticking out because it's the liver that's enlarged, pushing everything out. If we look underneath, we can see this sort of green bag. You see this little green squirt bag there? It looks green because bile tends to be greenish in color. There's a green pigment, not chlorophyll. But it's called biliverdin because it's bile green is the name of the color, biliverdin, which is actually a breakdown product of hemoglobin. It comes from the liver where red blood cells are broken down, and that's what gives all of this, the whole GI tract here before birth has this green appearance, all from that same bile pigment. So it comes from the bile. The bile is made by the liver but injected into the GI tract from the gallbladder or by the gallbladder. Now moving down around, underneath here we have the stomach, right? And the stomach, this is very muscular here. That's the pyloric sphincter that holds the stomach closed while it's busy sloshing around all of its stuff that it's doing in there. It keeps it sealed. And then it goes into the first section, the duodenum of the small intestine. If you just remember small intestine here. And between the stomach and the small intestine, you find stretched across the whole width of the abdominal cavity. You see this sort of whitish, right?
Pancreas?
He's trying to call me. That's the pancreas. Yeah. It's okay. Everything's all right for the review. Hello? Neil? I think maybe it's a butt dial. Oh, sorry, we'll just ignore that. So now we have, so there's the stomach and the pancreas. Here, small intestine, large intestine, and large intestine kind of looks like a tightly coiled snail here. Small intestine is all more loose. And notice it's smaller because it's thinner, but it's actually a lot longer than the large. Then we have where they join, right here is the end of the
This,
small intestine. This end of the small intestine goes into the large right about here. And then there's this dead end pouch here, right? The cecum, where stuff may stay for days while it's slowly being fermented and getting the the nutrients out of things like hay and stuff like that. Meanwhile, where food is being absorbed from the small intestine, anywhere you look, you just sort of push it apart,
Mistletoe.
and you see all the blood vessels draining the walls, and they go into these mesenteric lymph nodes where the food is inspected. The absorbed food particles are inspected for anything that doesn't belong there, like E. coli or whatever, right? So these are really immune system organs, just as the spleen is an immune system organ, the spleen being like the grand central station of lymph nodes. Okay, so spleen and mesenteric lymph nodes, lots of immune organs there. So these are the lymph nodes here. It almost looks like a continuous organ, but it's not. It's actually a string of individual lymph nodes. All right, and then, of course, the large intestine continues down toward the anus. You can see down here, but you can also see on either side the kidneys and the bladder. So you see all the organs of the excretory system as well. We'll be devoting a little more specific attention to those next week in the context of the excretory system, the function of the kidneys. And then this is a boy. You can tell because there's no ovaries here. It's what looks like a seatbelt, but actually what those are the sperm ducts coming up from either side. Right? And so that's the pig anatomy. So in the pig anatomy, it may be things like, instead of structure and function, there may just be some structure questions, like name this organ, name that organ, name this blood vessel, name that blood vessel, that sort of thing. All right. And that's the pig. Now we do the heart. Right?